there's none that just have closed up shop and don't communicate with the environment. To live is to interact with the environment. We must exchange two things, matter and energy. So here is a cell membrane, for example. I don't know what cell this is meant to be from, but it's a cell that has a transporter mechanism to bring glucose in. So you might imagine this is a muscle cell or a liver cell that needs some glucose for energy. It's also bringing in salts and oxygen and spitting out stuff that it doesn't want. So there's constant traffic in and out of cells all the time. Why do we need to interact with the environment? Well, the glucose, for one thing, would be there for energy. If you hope to have that muscle cell contract, it's going to have to bring in glucose. If it's going to have it in the bloodstream, you must bring it in from the outside environment of your body. But what's the other reason you might need that glucose? Pardon?
Well, I think like since something is going in and something is going out, it's more of like an equilibrium.
Yes.
And then the glucose is for the energy.
In a general sense, chemists would argue with that. It's not in equilibrium. That has a special meaning. Living cells are actually far from equilibrium, but there is a kind of a metabolic balance of some sort, in versus out. And you have to get rid of waste materials. You have to bring in sources of energy. This could be a glucose molecule. This could be a fat molecule for energy. What else would you need to bring in molecules like that for? What could the cell be doing other than just like
growing?
Right. So anytime you grow, anytime you make a new protein, anytime you build more DNA, if it's a cell that's about to divide, it's going to have to copy the DNA, so it means it has to build a whole bunch of stuff to do that. You need to bring in matter. Forget about the energy part of it. You need food. That's the second thing you need food for, right? You need food for energy purposes, and you need food just for the carbon and nitrogen and sulfur and all that stuff that you need to construct new parts. So you need it both for building blocks, sort of, or construction materials, and the energy to drive it. All the organisms that we know of have found a way to copy themselves. Replication is a fundamental property of all the life that we know about. And they store the information to copy themselves in DNA. And some cells just kind of divide in two. Some higher organisms have other mechanisms like sexual reproduction, where different cells combine, but there's always some way to reproduce the organism. In theory, you could say, well, why does it have to be? You could have an immortal organism. You could have an organism that's so good at fixing all the things that go wrong with us over time, the cell damage, the DNA damage, just keep repairing it and live forever, right? That is a theoretical possibility to have that. If there ever was such an organism, it got eaten by somebody else, right? So that tells you something about survival strategy. It's better to have 2 or 3 kids, and somebody survives likely, and the whole gene pool doesn't get consumed as lunch by somebody else. What's the other problem if you had an immortal organism?
Well, it wouldn't break down. We'd build up, and nothing would ever go away.
Well, you could have it get rid of waste products and stuff. It could be, the dream to be 28 years old for the rest of your life, right? If you could imagine a scenario like that.
So
Why
it's
not?
just a limited amount of people.
In the same stage?
Like take over.
Pardon?